welcome to chapter 7 and 7.1, and we're talking about rational expressions in this chapter, which is just basically a fraction. It's P over Q, but instead of these just being numbers like we learned in chapter 1, this back in another class, these are going to be polynomials on top of each other. So it'll be a polynomial over a polynomial, but this denominator cannot be 0. We're going to learn, and I'm going to demonstrate how parentheses are going to be very helpful when we're learning how to simplify these. But first, we're going to just practice by evaluating this. And this is what I mean by a rational expression. We have a polynomial over a polynomial. So I want to evaluate this when x equals 4 and x equals 3. So we're going to have two things here to do. So we first have our parenthesis of 4 minus 3 over 5 times 4 plus 1, which would be 1 over 21. Okay, that's the first one. And then we have 3 minus 3 over 5 times 3 plus 1, which would be 0 over 16, or just 0. So we simplified both of those after we evaluated. And that's all it means to evaluate, is to give a known value and to plug it into that rational expression. So I kind of mentioned that the denominator cannot be equal to 0. So we want to find out when our rational expression is undefined. Because if this denominator is 0, then that means that it's undefined, right? If it's 0 is under the line, it's undefined. So let me put a problem up here, and I'll show you how we're going to use those parentheses. So here we go. We have x over x plus 8. I always like to just put parentheses around there so that that glues it together. All that in the numerator goes together, and this down here goes in together. So if I want to know when is this undefined? So what makes fractions and rational expressions undefined? It's when the denominator equals 0. So I'm going to take this denominator and I'm going to set it equal to 0 to find out when I do not want it to be there, what x I do not want it to be. So I do not want this x plus 8 to equal 0, so that means I do not want x to equal 8. So when is this going to be undefined? When x equals 8. So our solution here, we do not want x equal to 8, not 0. Okay? All right, so let's do another problem. Values, let's find values to make the denominator equal 0. So we have x minus 3 over x squared plus 5x plus 4. So we want to know the values to make this expression undefined. So what makes rational expressions undefined? When the denominator goes to 0. So that means what value, we're looking for what value will make this denominator of x squared plus 5x plus 4 equals 0. So I'm going to bring that over here and say x squared plus 5x plus 4. We're going to set that equal to 0. Now we learned in the last chapter, in chapter 6, to find these values, we need to factor first. So we're going to factor, and we have x and 4. So what's 4 that adds up to get to 5 would be x plus 1, x plus 4. Okay? If you need a review on how to factor, you can go back to section 6.12, 6.8, I believe, and we can review those also. So equals to 0. So I factor this. So when I multiply this, x times x is x squared, x times 4 is 4x, x, and then 4. And then it would add up to there. So now I can see that we have x plus 1 equals 0, or x plus 4 would equal 0, x equals negative 1, or x equals negative 4. So if I plug x equals negative 1 in here, that's going to make the denominator go to 0. If I plug negative 4 in there, it's probably going to make it go to 0. So let's check and see if that's true. So I say that when we have x squared plus 5x plus 4, if I replace that with a negative 1 squared plus 5 times negative 1 plus 4, that it's going to equal 0. That's what I'm saying. I'm just going to put a box right here. That's our first rational expression. So this would be 1 minus 5 plus 4. Does it equal 0? Well, 1 plus 4 is 5. 5 minus 5, that's 0 equals 0. Yes. So I don't ever want to use negative 1 because it makes the denominator equal to 0. Let's try the other one here. We have negative 4 squared plus 5 times negative 4 plus 4. I'm saying it equals 0. This would be 16 minus 20 plus 4. 20 minus 20 would be 0 equals 0. Yes. So both of those numbers work, and they make it go undefined, make the denominator 0 and the whole rational expression equal to undefined. Let's try another problem. Okay. What value makes this rational expression go undefined? Remember, to be undefined, the denominator has to go to 0. Is there anything I can put in this denominator to make it go to 0? No, there's no variables. That's just 5. So this is not ever undefined. It's always a true statement. And always, I can put any number in there for x. So it's all real numbers. Okay, so let's talk about simplifying rational expressions. Okay, the first thing we're going to do is we're going to factor both numerator and denominator. And we're going to then divide out. Now this is where we're going to be really making use of those parentheses, and I'll show you why here in just a second. So we have x to the fourth plus x. Okay, so we have x to the fourth plus x cubed over 5x plus 5. We want to simplify, and just like we did with fractions, we want to take out what's in common. But this whole thing and this whole thing makes up one number. So those have to match identically if we want to factor them out. We can't just go, oh, there's an x, there's an x. That's not how it works. So let's factor these completely and see what we have. So in the numerator, we can factor out x cubed, and then we have x plus 1 left over. In the denominator here, I can factor out a 5, and I have x plus 1. Now I can factor out maybe an x cubed, only if I have an x cubed down here. But look, I have x plus 1 and an x plus 1. That is equal to 1. X plus 1 over x plus 1 is equal to 1. So what I'm left with is just x cubed over 5. Okay, let's do another problem. Here's another problem. We're simplifying this, so we need to factor the numerator, factor the denominator. I cannot divide these out. Remember, to divide them out, you have to have factors. These are all addition. So this is one whole thing here, and that's one whole thing. So they either have to match identical, or you have to factor things out from there. So let's look at this numerator, and the numerator we have 1 times 18. They're not perfect squares, so I got to do the AC method. 18 would be 2 times 9, and that does equal up to 11. So this would just be x plus 2, x plus 9. The denominator, we have a perfect square, but that's not a perfect square. So we have to have something that multiplies to negative 2, but adds up to a positive 1, which would be 2 and negative 1. So we have x plus 2, x minus 1. Okay, so now what's in common? Now we have a factor. Remember, factors mean we multiply. We have two things that are multiplying here, and we have x plus 2 and x plus 2 can cancel out. So we're just left with x plus 9 over x minus 1. Keep things in parentheses. When we get to multiplication and division, the parentheses are going to help you so much. I cannot stress it enough. I think I got one more problem here for you. Actually, I might have a couple more. X squared plus 10x plus 25 over x squared plus 5x. Once again, we're simplifying, so I need to factor this. This is one whole thing. I cannot factor out this. I cannot factor out the 5 from there or divide this. That is one whole polynomial. That's one whole polynomial. So let's look at the numerator. That's a square. That's a square. Is this plus 2 times x times 5? Yes. So then I can write this as x plus 5, x plus 5 over. Here I can factor out an x and I get x plus 5. I can only simplify out one of these because I have two x plus 5s in the numerator, but I only have one x plus 5 in the denominator. So the only thing I can cancel out is just one of these. So I'm left with an x plus 5 over x. These x's cannot cancel out because this in the numerator is x plus 5. It would have to be 5 times x to cancel out. When you have plus signs there, you cannot break them apart. They are together. Let's see, what else I got? Okay, I just want to show you this to bring it home some more. Over here, I have a common factor of x because this is x times x plus 3. Over here, these x's cannot be canceled because x plus 3 is all together. That's my numerator. So I cannot cancel it. This cannot be canceled, but this one can be canceled. I just wanted to show you a quick example of that. So I think I have a couple more here. We have x plus 5 over x squared minus 25. So remember, x plus 5 is together. This is all together. So I cannot factor x plus 5 anymore. So I'm just going to keep him there and put parentheses. X squared minus 25 is a difference of squares. So this would be x minus 5, x plus 5. When I cancel that out, what's left in the numerator is 1. It's understood to be 1 over x minus 5. And I keep that in a parentheses just so I can remember that that is one whole factor, x minus 5. That's, you have to have a product to divide anything out. Okay, last but not least, we have x minus 4 over 4 minus x. These look very similar, but they're not exactly the same. We have an x, yep. We have a 4, yep. But remember, these have to be identical. We have to have a positive x. That's a negative x. We have to have a negative 4. That's a positive 4. So what we can do is we can rewrite these or write equivalent forms. And the way we're going to write an equivalent form is take a negative out up here. So I'm going to take a negative out, and then this would be 4 plus minus x over 4 minus x. So now they look the same, and I can do this, and my answer is just negative 1. All right, so have fun with that. The main thing I'm going to stress again is you have to factor the numerator and denominator all the way, and you have to make sure you keep parentheses so that you remember that that whole thing goes together, and you can't just separate them out. If they have a plus sign, that glues them together, and they have to be identical to this to be able to factor them out.